Now that we have a little more experience with understanding the scientific method, I want to go back to the study section of our book and let's do these focus questions, the things that we need to be able to review for a test. So, the first question that I need to be able to ask or answer is, what is a hypothesis? Now, I can tell a couple of ways that we're talking about one hypothesis because of the ending on the word. That's not hardly dark enough, is it? So, one hypothesis. I also can tell you that because of the word is. If we were talking about more than one, we would say, what are hypotheses? So, let's answer this question. What is a hypothesis? And this is an old habit from college that I still follow. I want to answer in complete sentences. So we would say a hypothesis is, so I'm just turning that question around, literally. You don't even have to remember how to spell it. A hypothesis is a researcher's, so plural, possessive noun. A hypothesis is a researcher's educated guess or prediction about a research question. An experiment must be done to test a hypothesis a hypothesis is supported by the experiment. I'm not going to add that much. I'm just going to say supported or rejected. That is a very good answer to that question. Okay, the next question says, on what axis is the independent variable plotted? Well, the easy answer to that is the x-axis. So let's go ahead and answer the question. I'm not going to use a sentence this time because I don't have enough room. But I am going to draw an example for you on this graph. Okay, so the x-axis, first of all, is this one. It's the one that runs across the page. All right, so we're going to call that the independent variable. Let's go ahead and put an X there, just so you know. And I'm going to come down here and call it the independent variable. Okay. The dependent variable is going to be on this axis. Now, let me write this before you copy it. We're not going to put it in here. Just bear with me 1 second. I'm going to turn this around so that you can turn your book around, but I can't turn my computer around. This is the dependent variable that we're going to put right here. And I'm going to show you an example. Whoa, that's not a good thing, is it? I'm going to show you an example of what I mean by this. And let's go back to our example of Sam that we used in the last video. Let's suppose that one of the further research steps that Sam's doctor wants to do is to prescribe a blood pressure drug. Okay, so the independent variable in my graph here is going to be a blood pressure drug. And I'm going to measure that in milligrams. Okay, that's the thing that the researcher can control. The doctor can control the amount of the blood pressure drug that he prescribes. Sam can control the amount of the blood pressure drug that he takes. So let's put 4 different tick marks on our x-axis. And I'm going to put 5, remember these are milligrams, 10, 15, and 20 on my milligram line. And this is the thing that the doctor can control, that Sam can control. How many of these pills he takes is entirely up to him. So on the dependent variable, what is the dependent variable going to be? A dependent variable is a factor with a value that depends on the independent variable. So let's look at Sam's blood pressure, and I'm just going to look at the systolic pressure, that top number. So I'm going to say, again, do not write this. Just close your eyes for a second. I'm going to put the systolic pressure, that's the top blood pressure number. You could even graph both numbers on here if you wanted to do a double bar graph. I'm sorry, it's not a bar graph, it's a line graph. And that's coming up soon, I believe in our next chapter or maybe the next one. Okay, so systolic pressure. And I'm going to put some tick marks up through here on the dependent variable, because we're going to monitor Sam's blood pressure at each of these dosages of medication. So let's say, let's do it from 90 to 100. Let's go by tens, count by tens. And these are not bad numbers anyway. I'm getting into some bad numbers for that top number. So let's say that when Sam is taking 5 milligrams of blood pressure medicine, his top number is going to be 160, his systolic pressure. So let's color in a dot there at 160. So at 5 milligrams, his pressure is 160. When he increases to 10 milligrams of blood pressure medicine, what do you think will happen to his pressure? More medicine, lower pressure. So maybe at 10 milligrams, he's dropping here to 140. That's a good thing for somebody with high blood pressure. You want it to come down with the medication. So at 15 milligrams of medicine, maybe he drops to 120. That pressure's coming on down. And then finally, when he gets to 20 milligrams, the pressure is 100, which is tending a little bit toward low. So we wouldn't want to go much further than that. So let me just show you another conclusion that you can draw here. Look at how this pattern makes that nice stair step. It's very predictable. What this is telling me is that when I increase the dosage by 5 milligrams, systolic pressure does what? Is it increasing or decreasing? It's falling. Now, I am completely making this up. This would probably never happen in real life. But while I have you on this train of thought, we are increasing the medication by 5 milligrams, and his pressure falls 10 points. Sorry, 20. I'm about to lead you down the wrong path. Excuse me. His pressure falls 20 points. So I need to change that. And it's not milligrams, let's say points. It's actually a different measurement, but we're just going to say points. So every time the medicine increases 5, the line falls 20 points. Increase 5, the line falls 20 points. This is one way that science and math are related. They are hand in hand, brother and sister. The question is, on what axis is the independent variable plotted? The independent variable is something that can be controlled. That is on the x-axis. But while we're on this train of thought, this is a good thing to look at, the graph. Okay, this last one says to explain the difference between a scientific theory and a scientific law. Now, when I saw the word difference, I drew the Venn diagram. So let's complete this Venn diagram. On this side, I'm going to put scientific theory. And on this side, I'm going to put scientific law. And we want to know how these two things are different. They sound like the same thing, and they're sort of the same thing, but they're not the same thing. So how are they different? So going back to my text, the part that we annotated, I'm going to look back. Let me just go back and read that. I think that would be a really good thing to do. It's just that one little paragraph. So let's look right here. Evidence from research leads scientists to propose scientific theories or explanations based on experiments. A scientific theory is a logical explanation that is based on data and not a guess. For example, when you are playing the game Clue, you might say, I have a theory that Colonel Mustard killed Mrs. Peacock in the study with the wrench. When a scientist talks about a theory, like the black hole theory, they are referring to a well-tested explanation based on observations, research, and data. A scientific law is a rule of nature that sums up the related observations to describe a pattern in nature, and it is true all the time. The law of gravity is a scientific law. So let's go back to our Venn diagram, and I'm going to do the shortcut on this one. This is study questions. So let's first of all focus on scientific theory. A scientific theory is based on what? What did our passage tell us? It is based on experiments. Okay, scientific theory is an explanation of a scientific event. We could say that. We could say that a scientific theory is well tested. You don't get to be a theory without a lot of experiments. And that it's based on not only experiments, but observations, research, and data. Okay, that's a good summary of scientific theory. So what about scientific law? Scientific law is not based on experiments. What determines a scientific law? It is based on the laws of nature, the things that nature determines to be true. For example, when Newton observed the apple that fell from the tree onto his head, allegedly, it's a law of nature that the apple falls down. Instead of flying off into space, the law of gravity pulls the apple down. So scientific law is based on nature, and it's true all the time. Theories can be supported or rejected, but not scientific law. They're true all the time. Scientific law sums up theory in a way. Scientific law determines if theory is supported. So experiments suggest to us that theories are true or are not true. They're supported or rejected. But scientific law, there's no argument. It is true all the time. It is the way nature sets things up, not how man interprets them. Okay, one thing that I do want to show you here, and I'm going to change the color. On a Venn diagram, this middle section is always reserved for both. So how are the two things alike? How are the two things similar? Well, both are important in science. You need them both. Both of them can be used to explain nature. It's just that the scientific law cannot be challenged. It is true all the time. Theories can be tested and may be shown to be not true. But this diagram is this question is asking us to explain the difference between the two. So we are interested in the things that are in the differences category, not how they're the same. But if it asks you to explain how they're alike, you could definitely use this approach. It would work. So here's my answer in sentence form. A scientific law, I'm going to have to put it down here. It comes down to one very clear, simple fact. Well, I don't know that I would call it simple. A scientific law cannot be challenged. It's going to be true all the time because it's nature's way. A scientific theory can be challenged. You can test a theory, but you can't test a law. The law's already been tested, and it's proven every time to be true. So that would be one way to answer that question. But I did want you to see a Venn diagram. Okay, in the next video, I believe we're doing a writing activity about the scientific method. So I'll see you very soon, and I hope you have a good day.